Alright folks, what we have here is a problem number 6 from the review guide. We want to find the frequency of a radiation of a photon that has an energy of 4 times 10 to the negative 19 joules. So we're going to find an equation that deals with energy and frequency, and if we look to what we're given, we see that E is equal to Planck's constant times nu, that nu being the frequency. Since we're solving for frequency, the way we can rearrange this equation is if we divide each side by Planck's constant over here, that's going to cancel out, and we're left with frequency is equal to energy over Planck's constant. So now we can plug in this 4.0 times 10 to the negative 19 joules, and then we look up Planck's constant. I'll give that to you. That's going to be 6.626 times 10 to the negative 34 joules seconds. And if we plug this in the calculator, that should give us, let me see where it is there. That's going to give us 6.04 times 10 to the negative, to the positive 14. Now notice, what are my units going to be? Well, joules are going to cancel out, and we're left with just seconds on the bottom, or per second, which is the same as a hertz. And that's a respectable, or at least is what we would expect for our frequency, units. Now that we have our frequency, we can use the equation C is equal to lambda nu to find our wavelength, or our lambda. So in this case, we're looking for lambda. We're looking for this to get this all by itself. Let's just divide each side by nu. And now lambda is equal to the speed of light over nu. Speed of light, I would give that to you, but that's 3.00 times 10 to the 8th meters per second. And our frequency is what we just got in the previous problem, 6.04 times 10 to the 14 hertz, or per second. And if we look at our units, our per seconds are going to cancel, and we're just going to be left with meters. And we would expect meters for units for wavelength. It is a length after all. And if we do this, we should end up with 4.97 times 10 to the negative 7th meters for our answer for that one. If we looked at a spectrum, and I would give that to you if I asked you this particular question, but on the first page of this review guide, we have a diagram that shows the electromagnetic spectrum and corresponds it to frequencies and wavelengths. So if we looked for either this wavelength on there or this frequency on there, we would see that this frequency would fall somewhere in the visible band of light. Visible or somewhere near, I believe, the ultraviolet. But I wouldn't give you a problem like this unless I gave you a much clearer diagram than what was on the front of this. So that's how we would do this problems. Here we've kind of got best of both worlds. We've got an energy problem, and we also have a wavelength and frequency problem. All right, that's how we do these